We have our unit conversions of feet to miles and feet to yards and inches to feet and so on here, and the link between English and metric being 1 mile to 1.6 kilometers, okay? I haven't erased it because we don't actually need any new information at all to deal with surface area, and that's exactly the point of it here. Once you know how to deal with it as far as the technique I'm showing you here, drawing that horizontal line and letting your units cancel, you don't need any more information than this to tackle those problems. So let's talk about that here. Let's review briefly what surface area really is, okay? What you have, let's just draw a little picture. Let's draw a little rectangle, okay? When we have, forgetting about this rectangle for a second, when we have a unit of length, we have something laid out in front of you, and we say it's this long, okay? So you take a ruler or a meter stick or something, and you put it next to it, and you mark your fingers, and you say, okay, this one is, 0.5 meters long, or you can call it, 50 centimeters long, or 2 feet long, or whatever unit you're dealing with. It doesn't matter, but you're looking in one direction. That's what length is, okay? Area is when you're just starting to look in two dimensions, and that would be kind of analogous to, if you're trying to figure out how long something is, you put a ruler or a meter stick up to it to figure out how long it is. If you're interested in trying to paint a wall, something that has two-dimensional area, we call it, we call that a surface area, that would be trying to calculate maybe, for instance, how much paint you would need, not only to go in one direction here, going this way, but also to go up and down. You're looking at the entire rectangle, so to speak, of that wall. So it's more than just looking in one direction. You're looking also in this other direction. And the two directions kind of together define what we call a surface area. So you're not only looking in one direction, you're looking in two directions. And again, just a preview to the next section, when you start to look in the third dimension of depth, defining kind of a cube in front of you, that's volume. And we'll get to that in a little bit later, okay? So we have a rectangle. It has a length, right? We know that, and we usually write the length with a letter L, okay? And it has a width. Let's call it a width, and we'll call that W, okay? So it has a width. Now you should remember, or maybe you don't, but if you don't, it's not a big deal. Back from geometry or algebra or whenever you learn this stuff, the surface area of this rectangle, which is really telling you how much paint it's going to take to cover this whole rectangle. That's really the easiest way to think of surface area. It's this area here right in front of you, defined by the border of that rectangle. The surface area, okay, is very simple. It's the length times the width. That's all. So if you want to know, and it actually kind of makes sense to you, the more length you have, the larger the surface area. The more width you have, the larger the surface area. If you increase the length and the width, then of course the area gets bigger because the rectangle gets bigger. So it kind of makes sense that this is what a surface area would be defined to be, length times the width. Now, ask yourself the question, what unit of length do we use? Well, we've been talking about that all up until now. In the English system, you would use feet and inches and yards, okay? In the metric system, which is much more universally used everywhere, you would use meters or centimeters or millimeters or whatever. But it doesn't matter what unit you really use, you're all describing a unit of length, okay? So this is a unit of length, and of course the width is also another unit of length. So if you were looking at the units involved here, the unit of length, for the sake of argument here, let's say we're measuring it in meters, so I put an M here, some unit of, some 5 meters or 10 meters or however many meters it is, but it's a unit of meters, okay? And it's multiplied by the width, which is also measured in meters, okay? So I'm multiplying some number of meters by some other number of meters, okay? So in the end, when you multiply two units like this, and it's the same unit, you really can just write it as m squared, just like you would in algebra. Just like any variable, x times x would be x squared. A times a would be a squared. 3 times 3 would be 3 squared, 9, right? Here, it's not a number, it's just the unit involved, okay? So when you multiply them together, this thing, this m squared, meters squared, there's nothing magical about it, okay? There's nothing magical about it. All it means is that you've got 1 meter multiplied by another meter. That's it. And the reason they're multiplied together is because I'm multiplying a unit of length in one direction times the other unit of length here. So the unit of area is given by this guy right here. So this is the unit of area. Now, when you actually pronounce this, you can call it meters squared. A lot of times you'll see that. Like maybe you measure the surface area of your wall to be 6 meters squared. More commonly, the way you would actually say it, the way it makes more sense to say it, would be square meters. That's what you're really measuring, square meters. When you say something is 9 square meters, it means that when you look at this wall in front of you, I can take 9 square meters, 9 different squares, each with a length of 1 meter, and I can fit 9 of those squares on my wall if it's 9 square meters. A square meter being an actual square with 1 meter length and 1 meter width, right? I could fit 9 of those in the wall. If I had a building that I'm building for some giant building somewhere, and it was 100,000 square meters in surface area of the base of the building, that would mean that I could take a meter, which remember is about this big, take one length this way, one length this way, and make a square out of it, and I could fit, you know, however many thousand square meters in that surface area of the base of the building. So it really is a measure of how much area you can cover in 2 directions, basically, is what you're doing. So when you multiply the 2 lengths together, the unit that you use is a square meter, or a meter squared. Now, of course, if you're measuring it in feet, if you're using the English system, it would look like feet squared, okay? Because you're multiplying feet times feet. If you were measuring it in inches, it would be inches squared, because you're multiplying inches times inches. If you were measuring this in centimeters, it would be centimeters squared, right? If it was millimeters, it would be millimeters squared. If it was yards, it would be yards squared. You see the pattern here. No matter what unit of length you're using to measure this stuff, the unit of area is basically just that squared, because it's the length times the length, okay? So usually in your unit conversions, when you're trying to convert area, it's going to tell you, you have an area of 10 square feet. Let's convert it to square yards. Or maybe let's say, let's have an area of 10 square millimeters. Let's convert that to square meters. You see the pattern here. You start with a surface area in 1 dimension in square meters, which is nothing more than length times length, right? And you have to convert it to another unit of area, which could be any one of these, and of course others I can continue listing here, but these are all square units of length, because it's an area, right? It's 2 dimensions. The reason there's a square here is because it's 2 dimensions, 2 lengths multiplied by each other, okay? So, how do you handle this? Well, of course, if you actually had a book, and that book had a table that told you how many square feet were in a square inch, or how many square centimeters were in a square foot, or how many square millimeters were in a square centimeter, of course, if you had that tabulated, it would be really simple. You'd have a straight conversion factor just to use, just like we've been using up until this point, and then you would get the answer every time, no problem. It's exactly right, all right? The problem is, you're usually not going to be given that. You're not going to be given a table like that. You're just going to be given usually your units of length that you normally have, and you've come to know and love and use in previous chapters, and you're going to have to use this and nothing more. So for the purpose of the rest of the section here, we're going to work some problems, and all we're going to use is what we were already given in the last section, which is just different conversion factors with length. Now you'll see that because area is just length times length, it would kind of make sense that we should be able to solve the problems with only these conversion factors of length, because area is nothing more than length multiplied by length. So if we can convert length, we can convert area. That's what I'm trying to tell you, okay? So don't try to thumb through your book for crazy conversion factors to do this. I mean, if you have them, wonderful, use them. But if you don't have these, it's no problem. I'm going to show you that now. So let's go ahead and work some problems dealing with converting surface area units. Okay, now our first problem basically says, what if I want to convert 1 square foot, that's what that says, and I want to know how many square inches does that equal to, okay? And just to kind of give you an idea, I'm not going to do this for every problem, but I want you to understand what we're doing here. What does a square foot look like, okay? And I'm trying to give you an idea, what is this problem actually asking you? This is basically a foot. I mean, I haven't measured it with a ruler, but this is about a foot in actual distance I'm drawing here on the board. And this is a foot in this direction, okay? So if I'm going to make a square out of this, this is roughly a square foot. This is 1 foot in this direction, 1 foot this direction. That is what a square foot is. That's exactly what it means. 1 foot on each side, okay? You can actually draw it different ways. It doesn't have to be a perfect square. You can draw a long, thin rectangle and have the same surface area, but to make it easy to visualize, this is what a square foot looks like, okay? Now, in another color, let me draw inside of here. This is, again, by eyeballing it, this is roughly a square inch right here, okay? That's roughly a square inch. And again, I'm just eyeballing this. So this surface area is roughly 1 square inch because it's roughly 1 inch this direction and 1 inch this direction, okay? So what this question is really asking is, if I have 1 whole square foot, how many square inches can fit inside of that? That's what a conversion factor is. How many square inches is equal to this 1 square foot? You can see that you can take this little surface area of a square inch and you can fit a whole bunch of them inside of here, all the way down, zigzagging, zigzagging, and how many of those little square inches are going to fit inside of the square foot? Okay, that's exactly what we're asking ourselves here, okay? So that's just to give you a little visual overview of what you're trying to do with surface area. How are we going to actually tackle it? Well, you start out exactly how we've started out in the past. So you say 1 foot squared, okay? And then you just write an equal sign and you write it like this. 1 foot squared, don't forget, is equal to feet times feet. So you write it as feet times feet. That is the trick in this stuff. It's not really a trick. It's the way it always should be taught to people, but you'll probably regard it as a trick at this point in your career, okay? So basically what you do is you take the foot squared and you write it as feet times feet. It's very, very important to do that, and you'll see why in a minute. Now, if I wanted to convert one of these feet, so to speak, to inches, how would I do it? I would look up here and I would say, well, 12 inches in 1 foot. And I know that if I write it as in this orientation, 1 foot is 12 inches. I know if I write it like that, this unit of feet will cancel with this unit of feet, because I told you that any unit on the top and the bottom is going to cancel. Okay? Now, this doesn't really do the whole trick for us because, notice, I've canceled feet with feet, but I'm left with a foot on the top, and of course I've got this inch here, which isn't really helping me. It's not getting me totally to the answer I want. I need to get rid of this other foot. Okay? So what do? I look up here and I see I can use exactly the same conversion factor. So I write it down again. 1 foot is 12 inches. And what is that going to do for me? That's going to cancel this foot with this foot. Now, my friends, we have arrived at the answer, okay? We've started with 1 square foot, which is just feet times feet, okay? We've canceled the feet with this foot and the feet with this foot using the right conversion factor. So the final answer, all we have to do is take 1 times 12 times 12, and of course we're dividing by 1 and divided by 1, which doesn't really do anything. 12 times 12 is 144. And what units do I have left over? I have inches times inches. Inches times inches. And again, I told you from before, when you have units multiplied together like that, you just write it as inches squared. And notice this makes total sense from before, because all units of area should have square inches or square feet or square yards or whatever, and I arrived at exactly what I was trying to do. So you see, we converted our unit of square feet to square inches, but we actually didn't use a conversion factor of area. We didn't go look in some fancy table and find a bunch of area conversion factors and use them. We just used our knowledge of units, that this foot squared was feet times feet. We converted each of these feet to inches and we canceled them appropriately, and they were gone. There was nothing else. There, and we were left with inches times inches, which is inches squared. This is incredibly crucial stuff for you to realize, because every problem is going to be solved this way. Anytime you see square inches, square feet, square miles, square kilometers, square anything, okay, don't write it as inches squared. Don't write it as feet squared in your conversion table here that I'm teaching you how to do. Don't write it as yards squared. Always write it multiplied together, and know that you have to convert them individually, just as I'm teaching you, and you'll always get the right answer. Bulletproof every time. And believe me, even when I do have access to tables that list unit conversion area of surface area, I usually don't use them, because this you actually remember, because it works and it makes sense. You're not going to remember how many square inches are in a square foot. You're just not going to remember that. So let's go on and do another one. You'll find that there's a pattern here, obviously, that is going to serve you well, I think, once you see that. What if we had 2 square yards and I wanted to see how many square feet that was equal to? Now again, square yard, a yard's about that big. Here's another yard, so imagine a square yard. Now I have 2 of those square yards. Okay, so pretty big surface area. I want to know how many square feet, which is a square foot's a much smaller thing. How many of these square feet are going to fit in there? That's what I'm trying to find out. You're not going to find a conversion factor in most books that's going to list that. So all you do is you write 2 square yards, and you say it's equal to 2 yards times yards. Okay? Because yard times yard is yard squared. Okay, draw your line, and I know that I need to convert each one of these yards individually to feet. And I look over here and I see, and you probably just memorize this, that 1 yard is 3 feet. Okay, so I come over here and I write it like this: 1 yard is 3 feet. And I write it this way only because I'm trying to get the yards on the bottom to cancel with the yards on the top. So I don't flip it over and put feet on the bottom because that wouldn't give me any cancellation in my units. And I know I must do it again because I have 1 left over here. 1 yard is 3 feet. Okay? So again, this cancels with this. So you see, I'm done because I've gotten rid of both of my yards. I don't have any yards involved, and I'm going to be left with feet times feet, which is feet squared. That's exactly what I'm trying to reach. So 2 times 3 is 6. 6 times 3 is 18. 18 feet squared, or 18 square feet. 18 square feet. And you know, that kind of makes sense because if you have a yard, another yard like this, that's about a square yard. Now you have 2 of those, so pretty big surface area. 2 square yards is probably about the size of this board here, okay? And I'm trying to find how many square feet fit inside. Well, it makes sense that maybe 18 of these little square feet things would fit in such a big surface area. So that's exactly what we're doing. Okay. The next problem we're going to do, just to get more practice with it, 3 miles is equal to how many yards? Okay, 3 miles is equal to how many yards? And it's going to be actually square miles and square yards, obviously, because I'm dealing with surface area. So very big units here as far as area. So how are we going to do this? We're going to start with 3 miles, but we're going to write it out always as miles times miles. And you write it exactly like this: miles times miles. Okay? Now, we need to convert miles to yards. So we look over here and we see, can we convert miles to yards? Now, there's no doubt that you could go on the web or in a big book of tables and you could figure out how many yards were in a mile. You could do that. And it would be much shorter to do that, okay? But you'll see that I'm not really trying to teach you necessarily the shortest way to do things. I'm trying to teach you how to use this method so you'll always get the right answer, okay? Let's go ahead and use only what we have on the board to get this answer. And you'll see how powerful it is. So we don't know how to go from miles to yards, but we know how to go from miles to feet, and we know how to go from feet to yards. So we can get where we're trying to go, we just have to go 2 levels through it, or 2 conversions through it. So let's go from miles to feet, okay? We know that 1 mile is 5,280 feet, so we write it as 1 mile is 5,280 feet. And we write it like that because we want miles to cancel with miles. And we know we're going to have to do it again because we want to get rid of this mile. So we say, once again, 1 mile is 5,280 feet, okay? We extend our thing over to the right, and we know we're making progress because we've canceled both of our miles on top and bottom, and now we have feet times feet, okay? So now we want to get from feet to yards, which we have a conversion factor for. 3 feet is equal to 1 yard, okay? So we say now 3 feet is equal to 1 yard. And we do it again. 3 feet is equal to 1 yard. And we do it that way twice, again, because this foot is canceling with this one, and this foot is canceling with this foot, okay? So we have actually arrived at the answer. We've started with miles squared, we turned them into feet squared, feet times feet, and then we changed those in turn to yards times yards. So we went through 2 conversions, but we got there. So we started from miles squared and we got to yards squared. So all we have to do in the end, 3 times 5,280 times 5,280, okay? And of course we got 1, 1, 3, and 3 on the bottom. So what you're doing here to get the answer is 3 times 5,280 times 5,280 divided by 3 again. What you're going to get is a very big number. 9292800 yards squared, or square yards. So it's a big number. The number is really of no significance here. I just wanted to show you how to do that. You can go any number of ways to convert units. It depends on what you know. If you know that 1 mile is equal to so many yards, you could use it directly. If you know how many miles are in a centimeter and you know how many centimeters are in a yard, you could do it that way. I'm just picking a path here based on what I have written on the board for myself. So that's another disclaimer to tell you. In this entire DVD, I'm not presenting not even a smidgen of all of the unit conversions possible. I'm just giving you a flavor so that you can get started and understand the technique. So And this actually makes sense because you start with 3 square miles, which, think about that, that's a very, very large surface area. And it's going to take quite a bit of square yards to fit inside of that. So it's a whole lot. You know, it's 9 million, almost 10 million square yards. Okay, now the next problem is going to be similar. 343 inches squared, or square inches, is equal to how many square yards? Okay, how many square yards? Well, it's the same kind of thing. We're going to start with 343 inches squared, but we're going to write it as inches times inches. Okay, because we're always going to write our units like that when we're dealing with area. We're always going to write it out, inches times inches. Now let's see, can we go from inches to yards? We really don't have a conversion that's going to do that for us, but we can go from inches to feet, and then from feet over to yards. So let's do it that way. We know there's 12 inches in 1 foot, so we say 12 inches in 1 foot, and we're going to do it again, 12 inches in 1 foot. And we're going to do it that way just so we can cancel inches with inches and inches with inches. Okay, now we're going to try to make our way from feet over to yards. We know 3 feet is in a yard. 3 feet is in 1 yard. We're going to do it again. 3 feet is in 1 yard. And the reason we're doing it that way is, again, to cancel feet with feet and feet with feet. So we've gotten rid of everything except for the yards times yards, which is going to give us yards squared at the end of the day. So here's the same thing. You would get your calculator out and you would say 343 times 1 times 1 times 1 times 1, okay, divided by 12, divided by 12, divided by 3, divided by 3. So effectively you're taking 343 divided by 12, divided by 12, divided by 3, divided by 3, and what you get when you put that in your calculator is 0.265 square yards. Okay? So it's not even a whole square yard. So 343 of these little bitty square inches, 343 of these little bitty square inches is going to paint a big picture here right in front of us if we were putting paint on the wall, but that's not even going to be 1 square yard. It's going to be less than, just over a quarter of a square yard, so not that much. And that makes sense because the unit of square inches is very small, so even 343 of them, when you lay them all out, is only going to equal just over a quarter of a square yard, okay? So moving on to the metric system, you're not going to find any changes. If we were going to do 2 square meters and find out how many square centimeters that was, the exact same process is formed. There's no difference between the units because they're both units of length. So if we were going to do that, we would start and we would say 2 meters times meters. We're going to write always our square units of area down as unit of length times unit of length, and we're going to find out, do we know how many centimeters are in a meter? And we do. So what we're going to do is we're going to come over here and we're going to say that 100 centimeters is equal to 1 meter. So we have the conversion factor that we need, and we write it like this. 1 meter on the bottom is 100 centimeters on the top. We do it again. 1 meter on the bottom is 100 centimeters on the top. And the reason we do it in this order, with the meters on the bottom and the centimeters on the top, is so the meter can cancel with the meter can cancel with the meter. When one's on the top and one's on the bottom, they can cancel. What you're going to be left with is centimeters times centimeters, which is just centimeters squared, which is the unit of area that you care about. So 2 times 100 times 100 divided by 1 really isn't going to do anything. When you take 2 times 100 times 100, you're going to get 20,000 centimeters squared, because centimeters times centimeters, that's going to be your answer. Okay? And when you think about it, that kind of makes sense, because a square meter is a very big unit. A meter's about like this. This direction's like that. Pretty big. So you take a square meter, that's a lot of area. Then you have 2 square meters. A square centimeter, remember, a centimeter is about that big, the width of your thumb. A square centimeter is pretty small. It's going to take 20,000 of those things to paint 2 square meters, okay? So what if we're going to have 35 centimeters squared, and we want to find out how many square millimeters that's equal to, okay? So first let's start out with 35 centimeters squared, so I'm going to write it as centimeters times centimeters, okay? Centimeters times centimeters. Now let's look over here and see, can I go directly from centimeters to millimeters, and I really don't have anything written down. Now, those of you that are very familiar with the metric system, you might already know how many millimeters are in a centimeter. I could use that right now. I could use that number and I could put it in here and make it work. But just to teach you the power of the technique, even if I didn't know that, I can use what I have on the board to get there from here, because I know how many centimeters are in a meter, and I know how many meters correspond to how many millimeters, so I can kind of blaze a path through the conversion factors I have on the board to get to the answer. So going from centimeters to meters, there's 100 centimeters in 1 meter. So it's 100 centimeters to 1 meter. And I have to do it twice to cancel both sets of centimeters. Okay? So I cancel bottom with top, bottom with top. Now I need to go from meters to millimeters. And I know from my metric system prefixes, 1 meter is 1,000 millimeters. So 1 meter is 1,000 millimeters, and 1 meter is 1,000 millimeters. Okay? So that's that, and the reason I do it like that is so the meters can cancel with the meters, like this, and everything is canceled. The only thing I have left is millimeters times millimeters, giving me square millimeters, where I'm trying to go. And you see, I've done a couple of divisions here, and I've got a couple multiplications. So in your calculator, the way you would do this is 35 times 1 times 1 times 1,000 times 1,000 divided by 100 divided by 100. Okay? Now when you do that, you're going to get 3,500 millimeters squared. Okay? 3,500 millimeters squared, or 3,500 square millimeters. Now, for those of you that are much more comfortable with the metric system, you may have memorized, or you may know that there's actually 10 millimeters in a centimeter. It's something that you just may know, and a lot of people do, okay? You look at a meter stick and you're going to see the centimeters, and inside the centimeters you're going to see 10 little tick marks. Those are the millimeters, 10 millimeters to a centimeter. So I could have done this whole thing much easier. I could have started with the centimeters, and I could have said, okay, I know that 1 centimeter is 10 millimeters. 1 centimeter is 10 millimeters, and canceled the centimeters and gone from there. But you know, you may not remember that. You may not on your test know that little fact, okay? So what we did is we used what we knew. As long as you're canceling units in the legal way, you're always going to get to the right answer, okay? So the point is, when you're working your test, you may do things a little bit different than I'm doing them, depending on what you know. As long as you're canceling them correctly, and as long as you're using the same proper conversion factors, you're going to get the right answer. So my goal is to teach you the technique, not to memorize conversion factors, okay? Okay, now I'm going to conclude this section with 2 more problems that I think are kind of cool, because I want to show you the power of what you're dealing with here. It's almost like once you learn how to convert units, you're kind of playing with fire. You can actually invent your own conversion factors up. You know, if you flip to the front of your book, you're going to find a lot of times, or in the appendix in the back, a lot of conversion factors. And some of the books even dumb it down a little bit and tell you multiply by this to get this, multiply by this to get that. It's not really teaching you any knowledge about what you're doing. It's just teaching you a quick and dirty way to get things done. But you can actually invent your own conversion factors and use them to solve subsequent problems. So let me give you an example of that. Let's say I want to invent my own conversion factor. So let's say you wanted to actually invent your own conversion factor, and you wanted to know that 1 square inch, which again physically is about this big in actual dimensions, how many square centimeters would that be equal to? And this is the kind of conversion factor that you might actually see in a book, or you could certainly go off on the internet and figure out what this is, but you can derive it yourself, and I'm going to show you how to do that, and you already have the tools to do that, and you can use the answer to solve subsequent problems. So let's say you wanted to find this answer only what you had given to you on the board. With no other information, you had to figure out what this conversion factor is equal to. So you would do it in exactly the same fashion. 1 square inch is inches times inches, okay? And I want to go from, obviously, inches to centimeters, but I can't because I don't have inches to centimeters. So let's go from inches to feet. I can go from feet to miles. I can go from miles to kilometers to get me to the metric system, and then just go on from there to make my way on up to centimeters. So first, let's go from inches to feet. I know that there's 12 inches in 1 foot. So I write it like that, and I'm going to do it one more time because I have 2 of these inches to cancel. So I write it in this fashion so I can cancel inches with inches and inches with inches. Okay, now where do I go from here? Again, I'm trying to make my way over to centimeters, so I need to make my way to the metric system through this link down here. So I know that 5,280 feet, 5,280 feet is 1 mile. And I'm going to do it again because I've got to cancel two of these things. 5,280 feet is 1 mile. And again, I'm canceling the feet with the feet and feet with the feet. So now I've got miles. Now let's make our way over into the metric system. I know that 1 mile is 1.609 kilometers, so I can cancel 1 mile is 1.609 kilometers. And I know that 1 mile is 1.609 kilometers. Okay? And I'm doing it that way because I'm canceling miles with miles and miles with miles. So now I'm at kilometers. How do I make my way to centimeters? I can go from kilometers to meters and then from meters to centimeters, right? And I know that 1 kilometer is 1,000 meters, so I'm going to write it as 1 kilometer is 1,000 meters, and I'm going to do it again. 1 kilometer is 1,000 meters, and I'm going to write it like that because kilometers cancels with kilometers and kilometers cancels with kilometers. Okay? Now, finally, the home stretch. We know that 1 meter is 100 centimeters, so I'm going to write it as 1 meter is 100 centimeters, and 1 meter is 100 centimeters. Okay, you will see why I have made you endure so much pain to look at this giant list of conversion factors. Let's start from the beginning. I started with inches squared, inches times inches. I went from inches to feet, feet to miles, miles to kilometers, kilometers to meters, and meters to centimeters. Everything has canceled except for the centimeters times the centimeters, which is going to give me square centimeters. So in your calculator, when you actually take 1 times 1 divided by 12 times 1 divided by 12 times 1 divided by 5,280 times 1 divided by 5,280 times 1.609 divided by 1 times 1.609 divided by 1 times 1,000 divided by 1 times 1,000 divided by 1 times 100 divided by 1 times 100 divided by 1, you will get 6.45 square centimeters. Centimeters times centimeters gives me the square centimeters. Okay, so what you've done is solve this problem. Now, why did I pick such a long problem? I mean, obviously it goes all the way across the board. Why would I pick such a long problem? Because you've kind of invented your own conversion factors. You know that 1 square inch is 6.45 square centimeters. 1 inch is 6.45 square centimeters, okay? And what does that allow you to do? It allows you to solve further problems. Let's say you were given another problem that said, okay, now you have 32 square centimeters. How many square inches would that be? Now, of course, you could start out with square centimeters, centimeters times centimeters. You could go through all the mess all the way like we did and arrive at square inches, but now that I actually have this unit defined, I can start out with 32 centimeters squared. Now, in this case, I'm going to keep it as centimeters squared. I'm going to write it like this, and I'm going to use the conversion factor that I just invented. 6.45 centimeters squared is equal to 1 square inch. Okay, 1 square inch. And so the square centimeters cancels with the square centimeters. So basically what you're going to do, you're going to take 32 times 1, of course, divided by 6.45, and what you're going to get is 4.96 square inches. Now you see how much faster that was? I mean, because I had my conversion factor in hand, it was very easy for me to do it because I actually knew the simple conversion factor that I needed. This would be equivalent to what you might look up in your textbook and might actually help you out. But we actually invented that ourselves by looking at the units and going from the first unit all the way to the last unit, just taking it 1 unit conversion at a time. And that's why I say, if you just start at the beginning and logically go through it, making sure you don't make any mistakes along the way, canceling top and bottom with units as you go, you're not going to make a mistake and you're always going to get the right answer. So here we talked about unit of surface area, which isn't a big deal. It's just length times length, giving you length squared, inches squared, meters squared, yards squared, miles squared. It doesn't really matter. Length times length gives you area, okay? So by breaking it up like that, we can use our conversion factors that you probably are going to memorize anyway after a while to do those conversions, okay? In the next section, we're going to conquer volume, which is going to be, again, very similar to this. So if you understand this, the next section is going to be a piece of cake, okay? So don't freak out when you're trying to convert area if you don't know the conversion factor. Just take it one step at a time with your length, canceling top and bottom as you go. Make sure you do it 2 times because you have length times length, and you'll always get the right answer.
Learn anything at mathandscience.com.